In this video, we'll cover the problem single element in a sorted array. So here, we're given a sorted array of integers where every element appears exactly twice, except for one element which appears exactly once. We want to return the element who appears exactly once. We know this array is sorted and we know we're looking for a number, which tells us off the bat binary search is a pretty good option. So let's go ahead and talk about how we can use some sort of binary search to leverage properties of the array and find this one element which appears exactly once. I'm going to use this example because I think it is a little bit better for illustrating the point that I want to make than the first example. So let's label our indices here. Okay, now what we want to find is 4. We want to find index 4. So we can return value 10. That's what we want here. Now, one thing you'll notice is everything kind of comes in pairs, except 10. 10 kind of distorts everything. So one thing you should notice is every new number should be starting on an even index. 0 is an even index. So we start 3 here, we start 2. At index 2, we start the 7s. If there was no 10 at index 4, we would start whatever the next number is, and so on. But once we have this number, everything gets shifted. Now all of a sudden, all the new pairs are starting on odd numbers because everything was shifted by 1 by this individual element. So what we can do is whenever we grab an index and we want to figure out, hey, should I search to the left or to the right? What we can do is find an even index and see, does it work the way we expect it to? Where, let's say that even index is I. Do I and I plus 1 have the same value? If they do, then the shift must be on our right side. This single element must be on our right side because we have not yet been shifted. But if we pick an even number like 4 or 6, and we find that when we compare I and I plus 1, they are different values, then the shift must be to our left. And so we can kind of iteratively proceed with this process. So let's go ahead and see what this looks like in code. This is definitely a tricky one. So we'll have our right index is going to be last index here. And our last index is going to be nums.length minus 1. We'll have so long as our left index is less than our right index. We're going to do this a little differently. We're not doing less than or equal to here, and I'll show you why afterwards. So we're going to grab our mid index, which is going to be get mid index. It's going to be left index, right index. I'm going to come here, write that function. I'm going to get the mid. It's going to be left plus math.floor right minus left divided by 2, and we'll return that value here. Then we're going to come here and grab our mid value, which is going to be nums and mid index. No, actually, we don't even need to do that yet. The first thing we'll do is we only wanted to be looking at even indices because those should be the start of a pair. So we want to make sure we're at an even index. So I'll say if is odd mid index, then we'll just do mid index minus equals 1, or we'll do minus minus to be consistent with what I normally do. I like to write this is odd function. I think it reads a lot better than something like mid index mod 2 equals 1. I think it's just like, obviously this is asking if it's odd, and it's a nice little function here that'll just be like this. Yeah, that's a personal thing. So now we know we definitely are at an even index when we reach here. Then we can do something like cur and next values match, which would be nums at mid index equals nums at mid index plus 1. Cur value, next value. Yeah, we can store these in variables as well if we want to. I'm going to choose to do that. I don't think it's necessary. I think you could choose to leave it as what I had, but I personally prefer this way. So we'll do this. So this function is, or this boolean is going to be whether or not cur value equals next value. So if they match, what does that mean? Well, that's something like here. We know that clearly the current spot is not our single element, and the next spot is not our single element because these guys match. So we should look at I plus 2. We're currently at 2. We should look at 4 onwards. So we're going to say our left index is going to equal mid index plus 2. Then we're also going to say our else case, which is like, what if we're here? So we get our even index of 6, and it doesn't match the next element, let's say. Or even 4, actually. We can do 4. No, let's do 6. Let's do, so imagine we had some more numbers like this. Okay, so then we're at 6. Then what we want to say is, okay, the answer could be my current number, or it could be to the right. So we're going to say go to mid index minus 1. Like this. So if we look at our example here, we're going to say search everything to the right. If we were at index 4, then at that time, we would actually move our right index over here, and we would be crossing out of bounds. So we would break out of our loop, and our left index would contain the answer. So in the end, our left index should be pointing to the element that we care about. So we can say non-duplicate element, or non-duplicate is okay, is going to be nums at left index here, and then we can return non-duplicate. Let's see if this works. There might be a detail or two missing. Oh, I declared this as a const. We can make it a let. Okay, it works here. Okay, and it passes there as well. So the detail I want to cover, I guess 2. One is the idea that when left index and right index are equal, we've kind of found our answer. We've binary searched until we found our answer, and that's why we want to break out of the loop. So this is different from normal, where we say left index less than or equal to right index, typically. The other thing I want to say is that if we actually found our answer like this, then our right index should be crossing over to this side. And that way, as soon as the left index passes it, so like our right index is here, as soon as our left index is here, we break out of the loop, and that means our left index points to the answer that we actually care about, which is why we're using the left index here. Alright, well that's all for this video, and thank you for watching.